Dear students, today we are discussing about the important points of congruencies. On the congruency point, firstly we will be define about orthocenter. Orthocenter is the perpendicular drawn from the vertices on their opposite sides meet at a point. This point is called orthocenter. Here I have taken three types of triangle, dear students. Now we have to check whether the orthocenter lies inside the triangle in all types of triangle or not. Then next part is what is orthocenter. For that I will show you about the orthocenter and its location. Yeah. Let me highlight in first. I have to draw the perpendicular from vertices on their opposite sides. Yes, I have already prepared. This is the perpendicular drawn from this vertex to opposite side BC. Similarly, next from B to AC I have drawn another perpendicular, and the next that from C to AB line I have drawn the perpendicular. Now this is called orthocenter in acute angle triangle. It lies inside the triangle. Yeah, this is the orthocenter. Now let's move to the right angle triangle where the orthocenter lies. Now another here from vertex D to EF I have drawn perpendicular. You know this is already the perpendicular. This is right angle triangle. Similarly from vertex E to another side that will passes through this point as well. And next one is about this point EF that is perpendicular to this. Now you find where is the orthocenter. This point itself a orthocenter, that perpendicular from here and this point to that and this point to that. Here is the orthocenter of right angle triangle. Now moving to the next part, dear students, in obtuse angle triangle. Let me remove this part from these two of triangles. Now the last triangle you can see, uh, here is a perpendicular drawn from S to GI. Similarly, the perpendicular drawn from, yes, perpendicular drawn uh, from which vertex you can see the perpendicular. Let me highlight this. This I have stopped those perpendicular done from S to GI, which is shown now. Then this is the perpendicular drawn from this side to this side. If you have confusion, I will again show you from I to this line. Yes, that will overlap, so it goes this way outer side. Yes, perpendicular from this point to GH side. And then now last is again from G to this side, it goes by this way, and here is the intersecting point K, which is the what you guess, that is the K is the orthocenter of obtuse angle triangle. Now in sum, that in acute angle triangle that lies inside the triangle, in right angle triangle at the corner of right angle or at corner of right angle, and in obtuse angle triangle outside the triangle that also centralize, which is shown by the figure. Now dear students, we have to discuss about circumcentre. We will be observing the circumcentre among the three triangles. Now, what is circumcentre? The circumcentre is the perpendicular bisector of the sides of a triangle meet at a point. This point is called circumcentre. So we need here perpendicular bisector. In previous case about orthocenter, we have drawn perpendicular from this vertex to opposite sides. But now to find the circumcenter, we need to draw the perpendicular bisectors of the sides of a triangle. They will meet at a point. Let me highlight here. Perpendicular bisector I will draw from side AB. This is the perpendicular bisector, and the side BC, perpendicular bisector, and from side AC. You can observe this point is M point is called circumcenter of the triangle ABC, which lies inside the triangle. Now moving to right angle triangle, dear students, where the circumcenter lies, and let me find the perpendicular bisector of this side and this side EF and EFD side. You can see this is the circumcenter N. Yeah, circumcenter N on the hypotenuse of the sides. Yeah, that is the circumcenter. And now finally the next, let me uh, remove these uh, lines. Now the next is on obtuse angle triangle. Let me find the, yes, this is the perpendicular bisector of GI. This is of I, yes, and this is of this. Oh, like orthocenter. The circumcenter of obtuse angle triangle lies outside the triangle. So two things we have discussed about orthocenter and the circumcenter. I think I make you clear about in these two matters. Now we have to move to Incentre. Yeah. What is Incentre? First, let me define Incentre. The bisector of the internal angles of a triangle meet at a point. This point is called Incentre. No, in center. Yeah. Now let me find the bisector for internal angle. Let me find the bisector, angle bisector. Yes, angle bisector. Select 3 points here: B, A, and C. Angle bisector A, B, and C. Angle bisector. Then B, C, and A. Angle bisectors. Yes, now this is the in center of what? Acute angle triangle. Now moving to the next part, dear students, let me highlight the in center in right triangle triangle. In center in right triangle triangle, this is the angle bisector. Then E, F, and G, that is the another angle bisector. Then F, D, and E. Oh, this is also the in center of the angle bisector. It lies inside the right angle triangle in center as well. Now moving to the last triangle, that is in obtuse angle triangle. Let me check the angle bisector of H first, then H, G, I second, then G, I, and H second. So in center lies inside the triangle in the obtuse angle triangle as well. So in all the three triangles, that in center lies inside the triangle, either that obtuse or acute or the right, that in center in the meeting point of the angle bisector of internal angle of the triangles. Now we have to move to the next part about the centroid. Now we are discussing about the centroid. Firstly, what is centroid? Centroid is the median of a triangle meet at a point. The point is called centroid. So what is median? Actually, the line segment which joins the vertex to the midpoint of opposite side, that is median. Now we have to find the midpoint. Yeah, midpoint of each side. The midpoint, yes, and the midpoint and the midpoint. In every triangle, let me highlight or find the midpoint of opposite sides. Then this is the midpoint, this is the midpoint. I have fixed the midpoint of every side. Now we have to join this vertex to the midpoint, this vertex to the midpoint of opposite side, and this vertex to the midpoint of opposite sides. Yeah, now this point is called this point is called centroid. Similarly here, let me join by the line segment. These two line segments are joined and these three meridians are joined. This is another centroid of right angle triangle. This is an acute angle triangle. Now the centroid in obtuse angle triangle, this one, okay, and these two mirrors. Oh, interesting. All these points meet at a, sorry, all this line or median meets at a point this. So if we compare the centroid among the three types of triangle, in first, second or third, in all types of triangle, centroid lies inside the triangle, and incenter also lies inside the triangle, but orthocentre and circumcentres have different nature. Yes, in obtuse angle triangle that lies outside, in right angle triangle either in this vertex or in this hypotenuse, but in acute angle triangle all orthocenter, circumcenter, incenter and center all lies inside the triangle. In this way we can conceptualize orthocenter, circumcenter, incenter and centroid. Circumcentre, what is circumcentre? Perpendicular drawn from vertices to opposite side that meets at a point. Circumcentre, perpendicular bisector of the opposite side. Incenter, angle bisector meeting point. Center is median's meeting point. In this way, we can easily learn the nature of orthocenter, circumcenter, incenter and centroid. And also we know that if we measure here, we can find the length from A to this point. It's 2.69 and yes to this point 1.34. 1.34 to the 2.69. That 2 is to 1 ratio it will bisect. From here also you can find 3.59 and this is also 1.8. That's uh, 18 to the 36 nearly. Yes, some error will occur, but here 4.07 and this is 2.03. So this median centroid divides the median into 2:1 ratio. This can be verified. Okay, in this way we can learn more about orthocenter, circumcenter, incenter and the center. Yes, good. Dear students, now we are going to discuss a few more questions related to the concept given above. Now the question is find the equation. We have to find the equation that the line through the centroid of the triangle with vertices at 3 comma minus 4 minus 2 comma 1 and 5 comma 0 and parallel to x minus 3y equal 4, and in the second condition perpendicular to the line x minus 3y equal to 4. Okay, we have to discuss about the solution of this question. I will not go through I will not discuss in details, but I will give the information that will support you solve this question. First, we have to find the equation of the line. Yeah, through the centroid. Now we have to find the centroid. Before finding the centroid, what is centroid that we discussed earlier? Centroid is the meeting point of all the medians. So how to find the coordinates of the centroid? That is important here. So dear students, centroid, C-E-N-T-R-O-Y, the centroid of the triangle. Yes, of the triangle with vertices. What are the vertices given over here? 3 comma minus 4 minus 2 comma 1 and 5 comma 0. So as we studied earlier, the centroid is, suppose that is supposed by hk equal x1 plus x2 plus x3 over 3 comma y1 plus y2 plus y3 over 3. We have to apply this. Now what are the x coordinates? That is 3 minus 2 plus 5 whole over 3 comma first is minus 4 plus 1 plus 0 over 3 equal, what's the result is 5 plus 3 8 minus 2 6, divide that is 2, and minus 4 plus 1 is minus 3, divide by 3 is minus 1. This is what, this is the centroid. So if we know the centroid, that is centroid, we know the points. Now the line which is parallel to this, you have to suppose the line which is parallel to that line is what? Let me highlight, x minus 3y plus k equal to 0. That is the parallel line which is passes through this point. Yeah, using this point you can find the value of k. After finding the value of k, you can put here, then you can find the equation of the parallel line. For the perpendicular line, you can exchange this. What can we do? That is 3, just you can change the coordinates of that. Yes, if you have given ax plus by plus c equal to 0, what is the perpendicular line? Bx minus ay plus c equal to 0. In this way you can change the equation and which is passes through this vertex and use or find the value of k here, or see here k here, and find the solution. Now second type of question, dear student, we are discussing about next type of question which is given here. Prove that, yes, prove that the equation, yeah, of the straight line which passes through the point, which passes through the point, through the point a cos cube theta and a sine cube theta. Yeah, it's the point and perpendicular to the straight line, to the straight line x sec theta plus y cosec theta equal a is x cos theta minus y sin theta equal a cos 2 theta. This is the question. So I will not go through the details, but I will make you clear. Firstly, what is the perpendicular line? This line you have to suppose the perpendicular line to x sec theta plus y cosec theta equal to a is, that is what? Just interchange it. Y x sec theta, we have given x sec theta plus y cosec theta equal to 1 is x sec theta minus y sec theta minus x cosec theta equal to k. Okay, here minus k equal to 0, but sometimes we can do, I will rewrite this. Okay, we have to interchange here y sec theta, y sec theta minus x cosec theta, x cosec theta plus k equal to 0. Yes, I have corrected this. Yeah, now if you shift this k in that side, then it will be plus and it will be minus that k. After doing this, uh, after making this equation that is passes through this point, you can put the value of x. What is x? A cos cube theta. And what is y? A sin cube theta. You can put in this equation, then you can find the value of k. After finding value of k, you can substitute the value of k in the given equation and you will get this result. Hope it will be helpful for your solution. Now, third type of question, dear students. The question is, find the equation of the right angle isosceles triangle. A right angle isosceles triangle. We have to find the equation of this. Whose vertex is minus 2 comma 3 and whose base is x equal 0. Suppose we have given this question, dear students, then um, uh, the figure x equal to 0 line is this, then it will be like this, and minus 2 comma 3 will be like this. It goes like this. Yeah, the figure will be like this. And how can we solve this question is our problem. So first of all, the angle made by the sides, if we have given the name b, this name is q, then the angle made by the side pq, and this, if I have given this is r, and pr with y-axis r is of 45 degree. Yeah, and the angle made by the side PQ with x-axis is also 45 degree. Yeah, so m equal 1045 degree equal 1, we can find. Now the equation of side PQ. What is the equation of side PQ? PQ side is y minus y1 equal m x minus x1, and y minus this 3 y minus y1 equal to m x minus x1 is this is plus 2. Then y minus 3 equal x plus 2. So shifting that, yes, x minus y uh, minus 3 plus 2, that will be, what is x minus y equal what's that's a 5, yeah. If we shift both the side, yeah, it will be x 0 equal x plus 2 minus y plus 3. It becomes x minus y equal to 5. Similarly, the angle made by one thing let me highlight is minus 3. Okay, this point is minus 2 comma minus 3. Then here will be plus, here will be plus, here will be minus, and it will be 1 if the center is minus 3 comma 2. Yes, the angle made by, yes, made by the side, yeah, made by the side RV, x-axis, with x-axis, with x-axis is 135 degree. Yeah, so m equal 10 135 degree equal minus 1. So the equation is y minus y1 equal m x minus x1. I have written 2 comma minus 3 instead of 2 comma minus 2 comma minus 3. Instead that I have written firstly minus 2 comma 3. That's why some error occurs, so that doesn't matter. And y minus y1, what is y1 plus 3 equal m is minus 1, x minus x1 is plus 2, y plus 3 equal minus x minus 2, or y plus 3 plus x plus 2 equal 0, x plus y plus 5 equal to 0. That is the required equation of two lines. Upper one, this is x minus y equal to 1, and this is x plus y plus 5 equal to. Now very important and conceptual questions. Let me highlight the question here. Find the coordinates. Find the coordinates of the orthocentre, orthocentre and circumcentre of the triangle, whose vertices are 0 comma 1, 1 comma minus 2, and 2 comma minus 3. This is the question. We need to find orthocentre, coordinates of orthocentre, circumcentre of the triangle. Now the solution is, we need to find the solution of this. Yeah, first of all let me draw the figure, the triangle like this way. It may be 0 comma 1, it can be supposed by a, this may be 1 comma minus 2, and this c is 2 comma minus 3, and yes, anyway, yeah, the solution is, let a 0 comma 1 b 1 comma minus 2, C2 comma minus 3 be the vertices of the triangle ABC. Yeah. Now we have to draw, this is D, this is E. Draw AD perpendicular to BC and BE perpendicular to AC. Why we have drawn the perpendicular? Because we need to find the orthocenter. What is orthocenter? The perpendicular drawn from vertex to opposite side of the triangles meet at a point that is called orthocenter, and if two lines intersect, then third line also passes through the same point, that will be the same point. Yeah. Now we have to find the slope of BC equal, what is the slope of BC? Y2 minus y1 over y2 minus y1 over x2 minus x1. That's why minus 3 plus 2 over 2 minus 1 equal to minus, and we find the slope of BC. Since AD is perpendicular to BC, AD perpendicular to BC, so the slope of AD equal to 1, that is m1 dot m2 equal to minus 1. Nice. Now we have to find the equation of AD. Now equation of AD equal y minus y1. What are the coordinates of A? 0 comma 1. Yn is 1 equal m means that is 1 times x minus x1 is 0 using the coordinates of A. The equation is, what's the solution now? Y equal x plus 1. That is the first equation. Again, we have to find the slope of CA. That is, what is the slope of CA? That is also CA is y2 minus y1. Okay, y2 minus y1. y2 minus y1. 1 plus 3. 1 plus 3 by 0 minus 2. Y2 is supposed by A and X, Y2 and Y1 we have supposed. A to C, yeah. And now that is 3 plus 1, 4, minus 2 is minus 2. The slope of CA is minus 2. After finding the slope of CA, we can find the slope of BE equal 1 by 2 is m1 dot m2 equal to minus 1, and the region is a BE is perpendicular to AC. Yeah. So the equation of BE equal, that equation is y plus 2 equal 1 by 2 times x minus 1. Why did with this? Y2 minus y1. Y1 is what? 2 equal 1 by 2, that is m, x minus x1. Yeah. And doing this, that 2x plus 4 equal x minus 1, then 2y. Yeah. So it becomes x minus 2y equal to 5. This is equation second, of which BE. We find the equation of BE and we find the equation of DE. Now after finding the equation of BE and DE, now solving the equation of what? First one is AD and BE. We will get what is the equation of AD, that is y equal to x plus 1. This is the first. And what is second? X minus 2y equal to 5. This is second. You can substitute the value here. If we write x minus 2 times x plus 1 equal to 5, first value of y is substituted in y, second one, x minus 2x minus 2 equal 5, or minus x equal 7. Therefore x equal to minus 7. If x equal to minus 7, then y equal to minus 7 plus 1, that is minus 6. Then the points is minus 7 comma minus 6, which is the orthocenter of the triangle. Therefore the orthocenter of the triangle is minus 7 comma minus 6. In this way we find the orthocenter of the given triangle. Okay, dear students, you may not believe about that fact, but I will show with the help of GeoGebra. Look at here. I have drawn the triangle. Look at here. The first coordinates is 0 comma 1, second coordinates is 1 comma minus 2, and the third coordinate is 2 comma minus 3 as given in the questions. Now I have drawn the perpendicular bisectors. Again I will show you. It's okay. A perpendicular line from E to this line, opposite line. It goes like this way, and from EF to this line, and G to that line. And as I mentioned you earlier in the first phase, the orthocenter of a obtuse angle triangle lies outside the triangle. So here you can see S point is minus 7 comma 6, which was the orthocenter of this given triangle. So in this way also we can justify the result whether it is true or not. Now dear students, our part is to discuss about circumcentre. Before solving the numerical problem of the circumcentre, let me make you clear about what is circumcentre. Circumcentre, as we discussed earlier, that is the meeting point of perpendicular bisector of. Let me highlight here. Yes, I have drawn on perpendicular bisector, EFG another perpendicular bisector, and GE another perpendicular bisector. And this is the point of the circle. Yeah, this K point is the circumcenter. This is the circumcenter, and the circle passes through all the vertices of the triangle. So let me draw the triangle, circle through the point 3, this and this, and K is the center of the circle. Let me remove other points except K. Yes. Now if I join by a line segment all these vertices, these all are radii of the circle, all are equal. By using these points we need to find the coordinates of K. So to find the coordinates of K, here in the picture 5 comma 1 is already shown. This coordinates is what? 5 comma 1. By numerical method we have to solve. Before solving that question, the distance between EK, FK and GK are equal. We have to suppose this center is S comma K point, and we can solve this problem. Now the second part, that is now for the of the triangle ABC is, I have shown earlier, the circumcenter that is supposed by HK. Let the circumcenter be H, K. Then what we have studied earlier, HK point, yes, like this is H, K. Then from this point, and that point, this A point, this is B point and C point. These three distances are equal. So this is supposed by the center O H comma K, supposed by O H O B O H comma K. Now we have to find the, we have to use the distance formula. What is OA square? Simply 0 minus h whole square plus 1 minus k whole square. Why 0? Because the vertices of A is 0 comma 1. What is the vertices of B? 1 comma minus 2, and vertices of C is 2 comma minus 3. So in the first case we can apply this. It is h square plus k square minus 2k plus 1, or we can find OB square. OB square is what? OB square is 1 minus h whole square plus minus 2 minus k whole square. From this also we can find the result is h square plus k square minus 2h plus 4k plus 5. Similarly, OC square equal 2 minus h whole square plus minus 3 minus k whole square, minus 3 minus k whole square. And from this relation also what we obtain, h square plus k square minus 4h plus 6k plus 13. Okay, now how many equation we obtained? OA square, OB square and OC square. Since OSK is the center of the circle, so OA square equal OB square is O is the center of the circumcircle, yeah. O is the center of the circumcircle. All are ready. Now what will you get? Yes, what will you get? What is the result? That is important. Yeah. What is OA square? That is h square plus k square minus 2k plus 1 equal h square plus k square minus 2h plus 4k plus 5. This is. Now which can we cancel? This cancel, this cancel. Oh, then what is the next? From this, yes, 2k, 4k. While shifting that becomes, yeah, and minus 2 as 1 goes. Yes, we can shift 0 equal minus 2h plus 4k plus 5 plus 2k minus 1, or 0 equal, that is 2k and 4k is what? Minus 2h plus 6k plus 4, or what is 2 is common, minus h plus 3k plus 2. Yeah, therefore what is the equation? H minus 3k minus 2 equal to 0. IV we can give, if first, second, third we suppose this is IV. Yeah. Okay, now the next how can we find from OB square equal OC square? OB square and OC square you can check. Yeah. OB square what? H square plus K square minus 2H plus 4K plus 5 equal, what is OC square? That is H square plus K square minus 4H uh, plus 6K plus 13. You can see here. And H square cot K square cot. And from this solution, what we obtain, that is H minus K minus 4 equal to 0 we obtain. Equation P. You can solve this, okay? Now finally solving IV and B. If we subtract this one, this minus this, if we subtract H minus X cancel, minus 3K plus K is minus 2K minus 2, that plus 4 is plus 2, yeah, equal to 0, minus 2K equal to minus 2, therefore K equal to 1. And what is H? You can put here H. K equal to 1 minus 3 minus 2, that is H equal to 5. Therefore the circumcenter of the triangle ABC is 5, 1, which is already shown in the GeoGebra. I hope you are enjoying watching this video, and in the coming days I will make you clear in your problem, or if you have any doubt you can put your comment on the below box. Yes, thank you. Have a wonderful day. Thank you.